निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Welcome back, students. In this session, we will be studying chapter 2, polynomials, and we will be dealing with the solution of exercise 2.3. The very first question was, we are given in the question p of x and g of x, and we have to find the quotient and remainder when g of x divides p of x, or you can say when this polynomial is divided by this polynomial, you have to find the quotient and remainder. As we have talked earlier, we will have assigned a particular name, so that px is equals to x to the power 4 minus 5x plus 6, and the divisor through which we have to divide, that is the g of x and 2 minus x square. We will have to arrange in the decreasing order of power of x. I have told you earlier also before moving on to the division. If we look into p of x, it is in the decreasing order of power of x. Degree 4, then 1, and then 0. But in case of divisor, here the degree of x is 0, here the degree of x is 2, that means it is not in the decreasing order of power of x. So we will have to arrange it first. And this could be arranged as minus x square plus 2. Now we will be dividing p of x by g of x in order to obtain quotient and remainder, that is q of x and r of x. So let us continue with the division. X to the power 4 minus 5x plus 6 divided by minus x square plus 2. In any division, we have to first consider the first term of the dividend and the first term of the divisor in order to get the first term of the quotient. We will have to divide the first term of the dividend by the first term of the divisor to get the first term of the quotient. So let us divide. First term of the dividend divided by first term of the divisor, and we get as minus x square. So our first term of the quotient is minus x square. So minus x square into minus x square, x to the power 4, and minus x square into plus 2 is minus 2x square. We don't have any term x square out here, so let us write it somewhere apart from a distance from here so that it will be easy for us to take it. So let us write here as minus 2x square and subtract it. The plus sign becomes minus and the minus sign becomes plus. X square minus x square is cancels. Now the highest degree of the x is 2, so it should be written first. So this is 2x square minus 5x and plus 6. The highest degree first, of degree 2, then degree 1, and then 6. Again, we will divide 2x square by minus x square to get the next term for the quotient. So 2x square divided by minus x square is minus 2. So the next term in the quotient is minus 2. Minus 2 into minus x square is 2x square, and minus 2 into plus 2 is minus 4. Subtracting it, plus sign becomes minus and minus becomes plus on subtraction. 2x square minus 2x square is cancels. Highest degree of x is minus 5x, and plus 6 plus 4 is plus 10. Now the degree of x is 1 and the degree of the divisor was 2. Now the degree of the remainder is less than the degree of the divisor, that means our division has been completed. The division continues till the degrees are same. As soon as the degree of the remainder becomes less than the degree of the divisor, the division is completed. On division, now we have got the quotient as q of x is equal to minus x square the remainder r of x is equal to minus 5x plus 10. This way we divide a polynomial p of x by g of x in order to obtain q of x and r of x. There were 3 bits in this question. I have considered only 1 bit. The rest 2 bits are for your practice purpose. Then A. Moving on to the question number 2. Here also we have 3 bits. 1 I am solving and 2 is for your practice. Here in the question it is asked that check whether x cube minus 3x plus 1 is a factor of x to the power 5 minus 4x cube plus x square plus 3x plus 1. Is a factor of means what? In the division process, if the remainder becomes 0, that means the divisor is the factor of the dividend. That means if p of x is divided by g of x and we get remainder r of x to be 0, then we say that g of x is a factor of p of x else not. So let us continue again with the division process, but before moving, let us check the decreasing power of the variable x. 5, 3, 2, 1, 0. So there is no change in p of x. We did not change because it is already in the decreasing order of power of x. In g of x, 3, 1. Here also there is no need to change. It is already in the decreasing order of power of x. So let us continue the division and let us try or check whether the remainder is 0 or not. X to the power 5 minus 4x cube plus x square plus 3x plus 1 divided x cube minus 3x plus 1. As in the previous question, here also we will be concentrating on the first term of the dividend and the first term of the divisor in order to obtain the first term of the quotient. So let us divide the first term of the dividend by the first term of the divisor. Let us do from there here. X to the power 5 divided by x to the power 3, we have x squared. So the first term in the quotient is x squared. We need to multiply this x squared to each and every term of the divisor. So x squared into x3 is x to the power 5. X squared into minus 3x is minus 3x cubed. So this is minus 3x cubed. And x squared into plus 1 is plus x squared. Subtracting, we have to change the signs. Minus becomes plus and plus becomes minus, and this is cancelled. Then minus 4x cubed plus 3x cubed is minus x cubed. Plus x squared minus x squared is again cancels. Plus 3x and plus 1. Now, again we have to check the degree of the remainder. The remainder of degree is 3. This is 3. The degree of divisor is also 3. That means the division will continue. In order to get the next term for the quotient, we will have to again divide the first term by the first term of the divisor. So minus x cubed divided by x cubed is minus 1. So our next term for the quotient is minus 1. Multiplying this minus 1 with each term, we have minus 1 into x cubed is minus x cubed. Minus 1 into minus 3x is plus 3x. And minus 1 into plus 1 is minus 1. Subtracting, that means minus sign becomes plus sign, and plus becomes minus sign. X cubed is cancels, plus 3x minus 3x cancels, and plus 1 this is plus 2. Now the degree of the remainder is 0. The degree of the divisor is 3. That means the degree of the remainder is less than the degree of the divisor. That means the division is complete. And here the remainder is not 0. We have got remainder to be plus 2. If it would have been 0, then only we can say that the g of x is a factor of p of x. Here remainder is 2, so g of x is not a factor of p of x. Here r of x is equals to 2, which is not equals to 0, implies g of x is not the factor of question number 3. Obtain all zeros of 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5 if two of its zeros are root under 5 by 3 and minus root under 5 by 3. This type of question we have solved in our examples also. That was example number 9, where two zeros were given and a polynomial p of x was given, and we had to find out the remaining two zeros of the given polynomial. Continuing in the same way, let us write the polynomial first. That is p of x is given to us as 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5. Observing the polynomial, the highest degree of the polynomial is 4. That means this polynomial can have 4 number of zeros, out of which 2 are given to us, that is root under 5 by 3 and minus root under 5 by 3. That is, we are given with 2 such values of x, which on substituting in the polynomial makes the polynomial to be 0. That is why x is equals to 5 by 3 is considered as a 0 of a polynomial, because on substituting this value here, the value of x everywhere, this will make the polynomial to be 0. So 1 0 is x is equals to root under 5 by 3, and the second 0 that is given to you is as minus the root under 5 by 3. These are the two zeros. Both will be on substituting will make the polynomial to be 0. That means we can write this one as, changing the sign, minus 5 by 3 root under is equals to 0, and this side also we can write x plus 5 by 3 root under is equals to 0. This has been made from this itself. So we can say that x minus root under 5 by 3 is a factor of p of x, because this was 0 of the polynomial, and we can also say that x plus root under 5 by 3 is a factor of p of x, because this has also been taken from the equation of the 0 of the polynomial. If this is a factor of p of x and this is also a factor of p of x, that means the combination will also be a factor of x, that is the product of the two factors. That is, we can say x minus 5 by 3 root under into x plus 5 by 3, that is root under, and this is equals to 0. On multiplying, we can write it as x squared minus 5 by 3 is equals to 0. If you solve it, we can write 3x squared minus 5 is equals to 0. If you take the LCM, the denominator will be 3, and on changing the side, it becomes 0. So we can say 3x squared minus 5 is also a factor of p of x. Let me recall once again, two zeros were given to us. From the two zeros, we made two equations, each being the factor of p of x, x minus root by 3 and x plus root by 3, both are factors, and the product of the two factors will also be a factor of the polynomial p of x, that is 3x squared minus 5 is a factor of p of x. And let us denote this 3x squared minus 5 to be as g of x. Now when 3x squared minus 5, that is g of x, is a factor of p of x, then that means if p of x is divided by g of x, the remainder should come 0. And the remaining two zeros can be obtained by solving the quotient part of that division. So let us continue with that. Let us divide p of x by g of x. So this is 3x to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5. This was our p of x, and the factor that we had obtained as g of x is 3x squared minus 5. Let us divide it. In order to obtain the first value of the quotient, first term of the quotient, we will have to divide the first term of the dividend by the first term of the divisor. So let us do some work out here. Dividing 3x to the power 4 by 3x squared, we have x squared. So our first term of the quotient is x square. This x square is to be multiplied with each term of the divisor. So x square into 3x square is 3x to the power 4, and x square into minus 5 is minus 5x square. So this will be written here just below the square part. By subtracting, that means plus sign changes to minus sign and minus sign changes to plus sign. This is cancelled. Let us get the remainder. 6x cubed minus 2x square plus 5x square is plus 3x square minus 10x minus 5. The degree of the remainder is 3, which is greater than the degree of the divisor, so the division continues. In order to get the second term of the quotient, let us divide 6x cubed, the first term of the remainder, by the first term of the divisor. That is 6x cubed by 3x squared. So this is 2x. This is plus 2x. So 2x into 3x squared is 6x cubed, and plus 2x into minus 5 is minus 10x. Subtracting it, the plus sign becomes minus and the minus becomes plus. This cancels as well as this cancels. The remainder is 3x squared minus 5. The degree of the remainder is 2, and the degree of the divisor is also 2. That means the division will continue. So in order to get the next term for the quotient, let us divide the first term 3x squared by the first term of the divisor 3x squared. So 3x squared divided by 3x squared is plus 1. So this is plus 1. Plus 1 into 3x squared is 3x squared, and plus 1 into minus 5 is minus 5. Subtracting, the plus becomes minus and minus becomes plus, and this cancels. So the remainder is 0. Now we have divided the p of x by q of x and obtained the q of x. The quotient part is here. As I have told you earlier, that two zeros, root under 5 by 3 and minus root under 5 by 3, that are present in the divisor part, and the remaining two zeros we will be getting from the quotient part. So let us move to the division algorithm just to get the other two zeros. According to division algorithm, we know p of x is equals to g of x into q of x plus r of x. The g of x was the divisor, that is 3x square minus 5, which we have got from the two zeros that were given in the question. And q of x is x square plus 2x plus 1, which we got by dividing p of x by g of x, and plus remainder, the remainder is 0, so this is 0, and actually this is not required to write here. So here we will be getting root 3x minus root under 5, root 3x plus root under 5, and we will have to solve the quotient by splitting middle term. So this is, if you observe it, it is very clearly, you can say this is x plus 1 whole square. Or you can say x plus 1 into x plus 1. The way you want, you can say. Now we have got 4 factors of the polynomial p of x, from where these 2 factors we knew it because these 2 factors have been obtained from the two zeros that were given to us. The two new factors are x plus 1 and x plus 1. These are the 2 factors which have given us the 2 zeros. The rest 2 zeros can be obtained from these 2 factors. Now in order to be a 0, for the polynomial p of x to be 0, either this is 0 or this is 0 or this is 0 or this is 0. So let us find out all the zeros of the polynomial p of x. If it is to be 0, now for this to be 0, if this is 0, then we get x is equal to 5 by 3 root under. From here we get x is equal to minus root under 5 by 3. If this is 0, x is equal to minus 1. If this is 0, x is equal to minus 1. These are the 4 values of x which makes the polynomial to be 0. The polynomial p of x to be 0. That means these are the 4 values of x, and these 4 values of x can be called as the zeros of the polynomial p of x. Therefore, 5 by 3 root under minus 5 by 3, this is root under minus 1 and minus 1 are the zeros of p of x. Question number 4. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, that means this polynomial is to be divided by another polynomial g of x. The quotient and remainder were x minus 2 and minus 2x plus 4. That means the quotient was x minus 2 and the remainder was minus 2x plus 4, and we have to find that g of x that was dividing the polynomial. That means we need to find the divisor. So we are given with a polynomial, that is p of x is equals to x cube minus 3x square plus x and plus 2. G of x is actually not given to us. We need to find g of x. Again, we are given with q of x is equals to x minus 2, and we are also given with r of x is equals to minus 2x plus 4. P of x, g of x, q of x, r of x, all the 4 types of polynomials are given, which are actually used in the division algorithm for polynomials. So let us move with the division algorithm for polynomials. So according to division algorithm, P of x is equals to g of x into q of x plus r of x. We need to find g of x. So let us solve the first this equation by simple equation as we used to solve in the previous classes for finding x. So we can write this one as p of x minus r of x is equals to g of x into q of x. This plus rx can be shifted to the left hand side, it becomes minus. Now g of x into q of x is on the right hand side, and we need to find g of x. So let us move q of x again to the left hand side. So we can simplify the equation as p of x minus r of x by q of x, and this will be g of x. Now substituting the values of p of x, r of x and q of x and solving it, we can get the value of g of x. Let us substitute the values of this. So we can write g of x is equals to, what is the value for p of x? That is x cube minus 3x square plus x plus 2. This was by p of x minus r of x. What was r of x? Minus 2x plus 4. So minus 2x plus 4 and whole divided by q of x, that is given by x minus 2. Let us simplify it. This is x cube minus 3x square plus x plus 2 plus 2x minus 4 whole divided by x minus 2. And this is equals to x cube minus 3x square plus 3x minus 2 by x minus 2. Now we have simplified it. Both the numerator and denominator are in the decreasing form of the order of power of x. So let us divide the numerator by the denominator and obtain the value for g of x. Let us divide it. X cube minus 3x square plus 3x minus 2 divided by x minus 2. And the division follows same as we have done in previous classes. We will have to divide the first term of the dividend by the first term of the divisor to get the first term of the quotient. So x cube divided by x gives me x square. So x square into x is x cube, and x square into minus 2 is minus 2x square. Subtracting, the sign changes, the minus becomes plus and the plus becomes minus, and this is cancelled. Minus 3x square plus 2x square. So this is minus x square plus 3x minus 2. The degree of the remainder is greater than the degree of the divisor, so the division continues. Same way, the first term of the remainder will be divided by the first term of the divisor to get the first term of the quotient. Sorry, the second term of the quotient. So minus x square by x is minus x. So this is minus x square, and minus x into minus 2 is plus 2x. Changing the sign as we are subtracting it, this is cancelled. 3x minus 2x is x minus 2. Now the degree of x is 1 in the remainder, and the degree of x is 1 in the divisor. So once again the division will continue. So the first term, that is x, will be divided by the first term of the divisor, that is x. So x divided by x is 1, that is plus 1. So your next term for the quotient would be plus 1. So plus 1 into x is x, and plus 1 into minus 2 is minus 2. Subtract it, so plus sign becomes minus sign, and minus sign becomes plus sign, and this is completely divided, and remainder is 0. The quotient that we have got in the division process is actually what we were looking for gx. Therefore, we can say that gx is equals to x square minus x plus 1. Question number 5. Give examples of polynomials p of x, g of x, q of x, and r of x, which satisfies the division algorithm and a condition that is given to us as degree of p of x is equal to degree of q of x. There are 3 bits in this question. So we will be solving 2 bits, bit 1 and bit 3. And bit 3 you try it out yourself at home for practice. Now we will have to find all the 4 polynomials. We will have to make by ourselves those 4 polynomials, keeping in mind the condition that is given to us, that is degree of p of x should be equal to degree of q of x, and also it should satisfy the division algorithm. So let us try out. We need to find 4 polynomials with the condition that degree of p of x is equal to degree of q of x, and it should also satisfy the division algorithm. We can take any polynomial we want, but let us try out with smaller degrees, because if we move on to the higher degrees, it would be difficult for us to show that division algorithm is satisfied. So let us move on with smaller degrees. So you can take say degree 1, degree 2, or maximum you can try it for degree 3 if you want. I am moving on with degree 2. Suppose we want a polynomial p of x and q of x with the same degrees. So let me take any polynomial of degree 2. So x square plus 2, say, a very small polynomial. And let us also move on with the same degree for q of x. Let us take it as 2x square plus 1. So we will be taking x square plus 1. Now we have seen that both the degrees of p of x and q of x are same. Now we will have to frame 2 such polynomials g of x and r of x such that it satisfies the division algorithm. And what is our division algorithm? Our division algorithm is p of x is equals to g of x into q of x plus r of x. Here this divides this, so we get this and this. Or we can also say this way also, that p of x is divided by this, we get this and this. The process is same if you observe it minutely or if you carry out the process. So let us divide p of x by q of x to get g of x and r of x. Let us perform it in the rough part only, that x square plus 1 divides x square plus 2, that is p of x is divided by x square plus 1. Since the degree is 1, this is 1, x square by x square, following the division method, the first term of the dividend divided by first term of the divisor will give me the first term for the quotient. So this is x square, and 1 into 1 plus 1, subtracting, that means changing the plus sign to minus signs, this cancels and then this is 4. So we can write g of x as, this was our q of x, p of x, now this one will be g of x and this is r of x. So you can write this one as 1, this one as 1. Since you may ask, sir, this is not a polynomial, there is no variable. These are polynomials, these are called constant polynomials where the degree of x is 0. So this is also considered to be a polynomial. You can take any example you want. You can change the expression for the polynomial p of x. You can change the expression for the polynomial q of x, but keeping in mind the condition that the degree should be same. This was just an example. You can carry out with other examples also. Moving on to bit third, same way we have to frame 4 polynomials p of x, g of x, q of x and r of x, with the condition that the degree of r of x should be 0. Where the degrees of r of x is 0? Naturally, it's a constant value where the degree of x is 0. We have just seen in the previous example also that 1 is a constant. Here the degree of x is 0. That means each and every constant value will have degree of x to be 0. So we can take any constant value here, say 5, such that this 5 has a degree r of x to be 0. Now these 3 are to be framed by ourselves in order to satisfy the division algorithm. We can take any algebraic expressions to make such polynomials, keeping in mind that it should satisfy the division algorithm. So let us take the smaller ones, smaller degrees. We will say that let q of x we can take x and g of x we can take x squared, and p of x can be obtained by the division algorithm. And what is the division algorithm? That is p of x is equals to g of x into q of x plus r of x. Substituting all these values, x squared into x plus 5, so this is x cubed plus 5, so we can put this here for our polynomial p of x. You can take anything whatever you want for gx and qx, because we have satisfied the condition that was given in the question, keeping the degree of the remainder as 0, and then the 3 that are to be framed, g of x and q of x, can be taken by you as you want. Just we have to keep in mind that everything satisfies the division algorithm. This was one of the examples that was taken. You can try out with other examples